Here's some more practice in finding oxidation numbers, and notice that this time we're being asked to find sulfur, which there's no rule for in our list of oxidation numbers. So we need to use the rules for the elements that we do know, and also the fact that the sum total of the oxidation numbers has to equal the overall charge. So for something like our first example here, it's a neutral molecule, so the sum total of the oxidation numbers has to be 0. Now we don't have a rule for sulfur, but we do have a rule for hydrogen that when it's bonded with a nonmetal, it usually has a +1 oxidation state. Now moreover, we have 2 hydrogens, so that gives us an overall of +2. So to zero it out, to balance, the sulfur has to have a -2 oxidation state. Another way you can think of this mathematically is that we have 2 hydrogens, and the oxygen state on each one is a +1. And we add to that whatever the oxidation state is on the sulfur, and that has to equal the overall 0 for the molecule. So if you do it like that, 2 plus the sulfur has to equal 0, then the oxidation charge on the sulfur definitely has to be a -2. Now the next one, S8, is an elemental form. It's not bonded to anything, and your rule number 1 says that the oxidation number of a pure element is always equal to 0. So for this one, the oxidation state of sulfur is 0. Now for the next one, we don't know anything about sulfur again, but we do have a rule for halogens that they are typically -1. So again, if I want to set this up mathematically, the oxidation state of my sulfur plus the fact that there are 2 chlorines, each with a -1 oxidation state, has to equal the total of 0 for the molecule. So sulfur plus -2 equals 0. The sulfur this time has to have an oxidation state of +2. So in dihydrogen sulfide, this first one, sulfur has more electrons than it does in the second one. Now, this next compound, we have 3 different things. We've got sodium, sulfur, and oxygen. Now, we do have a rule for sodium. This is an ionic compound, so it's going to have a +1 oxidation state, that ionic charge. So we've got 2 sodiums, each with a +1 oxidation state. Add to that whatever the sulfur is, and now we also have a rule for oxygen, that it almost always has a -2. Now we've got 3 oxygens times that -2 oxidation state equals 0. And if you add that all up, 2 minus 6, you get sulfur minus 4 equals 0. So the oxidation state on the sulfur has to be a +4. Now for this last one, again, we don't know sulfur. We have 4 oxygens. Oxygen always has a -2 oxidation state. And this time we're not equaling 0 because it's no longer a neutral molecule. It's the polyatomic ion with a -2 charge. So the sum total equals -2. So we're seeing sulfur minus 8, 4 times -2, equals -2. So sulfur must have an oxidation state of +6.